So this picture is of a toy airplane. Actually flies, but it's attached to the controller with the wire. So if the student or if a child were to be standing still and flying with it, describe the shape of the flight path of the toy plane. If you're standing still, the only thing it can do is fly around in a circle. So flight path would just be a circle. It can circle around the top of the head of the kid. And that's exactly what they do if you ever see one. The reason for that is that wire acts like the radius, the controller acts like the center, and all it can do is spin around just like a compass would or anything else. So here we've got a triangle or a circle inscribed in a triangle. So all of those segments are tangents, which means all of the tangent segments to the same point are congruent. So since this is 5.6, z is 5.6, this is 2.7, so x is 2.7. Then the hardest side to find would be y here because we first have to subtract. So if that's 2.7 and the whole thing is 20, that needs to be 17.3, 20 minus 2.7, which means y is also 17.3. It also asks for the perimeter, so you need to add all that up, and you get the perimeter is 51.2. Here we have a central angle. The angle is in the center of the circle. So the angle will equal the arc. The angle will equal the arc. So subtract the 4, you get 117 divided by negative 13. X equals negative 9. Given the circle below with a radius of 15, so look for a radius drawn in here, center to the circle, that's 15. The distance from the center to the chord, so here's the chord, from the center to the chord, that's the distance, it's 12. Find the length of the chord. So we had a little theorem that said if you measure the distance, which will be perpendicular, it's also going to bisect the chord. It's going to cut the chord in half. So we do have a right triangle here, so we can solve that right triangle, 12, 15. We can find the third side with the Pythagorean theorem, or we could use Pythagorean triples to help us out. This is 5 times 3. This is 4 times 3. There's a Pythagorean triple, that's a 3, 4, 5. Here's a 4, here's a 5, so that means this needs the 3. Our multiplier was 3, so it's 3 times 3. So that side is 9. If you didn't remember Pythagorean triples, you just do Pythagorean theorem. 15 squared equals 12 squared plus x squared, and solve that out. So regardless, no matter how you do it, you get that this side right here is 9, which means the other side of the chord is also 9. So the entire chord has a length of 9 plus 9, 18 centimeters. When two tangents form an angle, there's a whole lot of relationships going on here. First, you've got the big arc and the little arc. Together, that's the entire circle. So 360 minus 225 tells us the little arc over here. 135. And then you have your choice of two formulas. You can all use the angle equals the big arc minus the little arc divided by 2, or the angle and the little arc will always add to 180. Take your pick. So I like the angle and the inside arc always add to 180. So if this is 135, that means the angle must be 45 degrees because they have to add to be 180. So then we have a simple equation this way. 8x plus 5 equals 45. So 8x equals 40, x equals 5. The angle and the inside arc add to 180. We have tangents and a secant. For a tangent, you always square whatever the length was. For a secant, it's the outside piece, 4, times that entire length, 4 plus 12, which is 16. So 4 times 16 is 64. So x squared equals 64, so x equals 8. The angle is formed by two chords. The angle in the middle equals the two arcs added together and divided by 2. So that's 150 divided by 2, 75. Same question. The angle in the middle equals the two arcs. Added and divided by 2. When you add that, you get 196 divided by 2. Here's another tangent with a secant. The tangent segment squared equals the outside portion, 2, times the whole length, 6 plus 2 is 8. 2 times 8 is 16. So G equals 4. On the area of a sector and the length of an arc, if you know what fraction of the circle it is, then just use that fraction. So if it was half the circle, you would just do half. If it was a quarter of the circle, you would just do a quarter, 1/4. You don't know what fraction that is, and you just know the degree. You take the degree out of 360 because that's the fraction of the circle. 115 out of 360 total degrees. So you take the fraction times the formula for area, which is pi r squared. 3.14 for pi times the radius, which is 5, squared. So you take 5 squared, which is 25, times 3.14 times 115, and then divide it all by 360. And you get about 25.076. Doesn't tell us how far around, so I'll do 3 decimal places. And that is yards, and since it's area, it's yards squared. For arc length, you do the exact same thing, but instead of pi r squared, you do 2 pi r. So times 2 times pi times r. You multiply it the same way. 5 times 3.14 times 2 times 115. Then divide by 360. And you get about 10.03. 0305, so you could round that up to 10.031 yards. That's just length, so it's just yards. This is a pretty in-depth problem. It starts out by giving us the area of a sector. It's 17.67 square feet. So we're going to fill in everything we know for area of a sector. Equals the angle over 360 times pi times radius squared. We're going to fill in everything we know. The area is 17.67. The measure of the angle, we don't know, so we're going to leave that as m. Pi, we're going to use 3.14. The radius is 7.5, and we need to square that. So to solve this, I'm going to take all the numbers on the right side and put them together, just remembering that it's times m. When you put them together, you do 7.5 squared times 3.14. And then we have this over 360, so we're going to divide by 360. You get all that together, and you get 0.490625 times m. So to solve for m, you just divide by that number, that 0.490625. 17.67 divided by 0.490625. And you get m equals 36.015. So let's round that to 36 degrees. So now that you know the angle, now you can find the length of that segment using that same formula, length, or a very similar formula, not the same formula. Length equals m over 360, so 36, because we know the angle now, times 2 times pi times r. And you multiply all that together. You get 4.71. Multiply it, divide it by 360, 4.71. The units of measure here are feet. So we know the center of the circle and the radius. We just need to write the equation. The equation of a circle is x minus h squared plus y minus k squared equals r squared. You fill in h, k, and r. So x minus -6 is +6. Y minus 4 equals r squared. 5 squared is 25. If they give you, rather than giving it to you written out in words, if they give you the graph, you're doing the exact same thing. You're just going to look in the graph for where's the center, and then count the radius, and plug it all in the same exact way. Is 6, 5 a point of tangency to the equations below? A point of tangency is a point on the circle. So when you plug in x and y, 6 and 5, it just needs to be true. So when you plug in 6, you get 0 squared is 0. You plug in 5, you get 0 squared is 0. 0 does not equal 25. So no, that's not a point of tangency to that circle. Do the same thing for B. Plug in 6, plug in 5. That's 3 squared. That's 4 squared. 9 plus 16. That does equal 25, so that's true. So yes, it is a point of tangency. So when you have a general form equation like this and you're trying to get standard form, you first have to set it up, because what we're going to do is complete the square 2 times. So completing the square, we need to set it up so we get x squared and then our x, -8x, and a blank, plus blank. And then we do the y squared, plus 10y, plus blank, equals, we want this 37 on the other side, so we move it over by subtraction. And now we're ready to go. You gotta fill in the blank. You fill in the blank with b over 2 squared. So you take the 8, -8 divided by 2, which is -4, and you square it to get 16. If you add 16 on the left, you have to add 16 on the right of the equation. And we complete the square. So we're going to rewrite this as x has to multiply to be 16 and add to be -8. That's -4 and -4. You do the exact same thing with the y's. Half, so b over 2 is 5 squared is 25. If we add it to the left, you have to add it to the right. So when we now factor that y squared plus 10y plus 25, that's just y plus 5. 5 times 5 is 25, 5 plus 5 is 10. Equals, now we add all these numbers up, so that is 31, 41 minus 37 is 4. So there's our equation. For the center, you just have to change the signs. So the x-coordinate of our center is 4. The y-coordinate is -5. And then the radius, remember this is radius squared, so that means the radius is 2. So then we graph. We plot the point 4, -5. That's our center. Since the radius is 2, you go 2 units up, 2 units right, 2 units down, 2 units left. And then draw a circle. There's our graph. When you have an equation that asks for the coordinates of the diameter, it's these 4 points that we just graphed. The horizontal diameter are these 2 points. The vertical diameter has those 2 endpoints. So here we are in the next question. That's exactly what we're going to be doing at the end. So we need to first get it ready. X squared plus 6x plus blank, y squared minus 12y plus blank equals, move that 29 over, negative 29. Now we fill in the blanks. 3 squared is 9, so we add 9 on both sides. 6 squared is 36, so we add 36 on both sides. So this is x plus 3 squared. This is y minus 6 squared. And you add all that up, that will be 45 minus 29 is 16. What's the center of the circle? Change the sign. It's negative 3, positive 6. What's the radius? This is r squared, so the radius is 4. And then the endpoints of the diameter. So it doesn't specifically tell you to graph it, but I would say you might want to graph this. Doesn't have to be perfect, but we go to negative 3, 6, negative 3, and up to 6. That's our center. And then from there, we're going 4 units up, 4 units right, 4 units down, and 4 units to the left. So now we have our vertical diameter and our horizontal diameter. The horizontal diameter, here's one of them. That's negative 7. And the height is 6. The other endpoint over here is 1, same height. For your vertical diameter, we're taking these 2 endpoints. That's negative 3, 2. And negative 3, 10. Here's another question. It doesn't explicitly say to graph, but I would certainly graph. So you can see if the points are inside the circle or not. So you start by graphing this. The center, change the sign, 3 comma negative 2. There's your center. And then the radius is 4. So we go up 4, right 4, down 4, left 4. So we just got to figure out if each of these points are inside the circle or not. -1, 0. Oh. 0, -1. Yes. 6, 1. Nope, looks like it's just outside. And 3, -3. 3, -3. Yep. So here we've got two circles with some tangents. They actually share tangent lines. BC is a tangent to both, and AB is a tangent to both. So what can we say about AE, CE, as well as DE and BE? So AE and CE are congruent because they're tangent segments, and DE and BE are congruent because they are also tangent segments. So what theorem? You call it tangent-tangent. You can just say tangent segments are congruent. Something along those lines, either by saying tangent-tangent or tangent segments are congruent.